Okay, hi you guys. Today we're going over solving a linear system by substitution method, but I just want to kind of recap on what we've done so far. So we've been looking at solving a system of equations. And when we solve a system, the solution is the x and y value that would make both equations true. And we recently found that you can actually find the solution by using what we call the graphing method. And that's what we did a few days ago. Remember, we would take the equations and we would graph the line and graph the line, and then we would see where they cross. And if they crossed down here at 2, 3, we'd say the solution was true 3 because that's where they intersected, right? That's where the lines intersected. And remember, what if we graphed and the lines didn't intersect? What if the lines were parallel and they're never going to intersect? Then we say the answer was no solution. And that's using a more graphical approach to finding the solution. But there are two other methods. There's actually a lot more other methods. But in Algebra 1, we really just teach the 3 methods. The graphing method. Today we're going to go over the substitution method, which is an algebraic approach to finding the answer or the solution. And then later on down the road, we're going to go over the elimination method. So today we are here. And we are going to go over how to solve using the substitution method. Okay, so that's where we're at today. Okay, so these are the steps to solving using the substitution method. So the first step is to isolate any variable of your choice. However, it's always smarter to isolate the variable that has a coefficient of 1 if there is one. That would be the smarter choice, but it really doesn't matter. And I'm sure your teacher will go over examples of that and why that is. And then the second thing after you've isolated, step 2 is to substitute the expression into the other equation. And then step 3 is to then solve that equation. And step 4 is then to resubstitute to find the other missing variable. And then it's always smart to double check your answer to make sure that you didn't make a mistake. And remember, we practiced verifying or checking our answer. And remember, that means you want to take your solution and you want to plug it into the values back into both equations and see if it makes both of them true. Otherwise, you've made a mistake and you have to go find that mistake. So you should be copying down those steps, right? You should pause the video and you should be copying those steps down. So let's, for problems 1, 2, 3, and 4 in this example, let's just focus on step 1. According to step 1, you can isolate any variable of your choice. So let's just look at this for a second. Let me pull this down here. So if I had the first equation, which is 2x plus 3y equals 4, right? This is equation 1 and this is equation 2. I can isolate any variable of my choice. So if I chose to get x by itself, then I would have to subtract 3y from both sides. Don't copy this down, right? You can't combine those because they're not like terms. I'd have to divide by 2. Look at all the steps that it's taken me just to get the x isolated. And I've ran into a lot of fractions. So notice that I got into a lot of fractions, but I got x by itself. And that's what we mean by isolate, to get a variable of your choice. Well, maybe, Johnny or whoever says, nah, Mrs. Whip, I decided to isolate the y. So if he decided to isolate the y, then he would have subtracted 2x from both sides. And then he would have to divide out the 3 to every term. And then he got y by itself. But he also ran into a ton of fractions. But notice he isolated the y. You only have to isolate one of the variables. So notice the first equation, it's not smart to isolate any of those variables because we get into a lot of fractions and it was a lot of work to do that. So notice it says it's always best to isolate the variable that has a coefficient of 1 if possible. So if we look at this example, which equation, top equation or bottom equation, would be the smartest variable and which variable to isolate. So if I get to choose, I'm going to work smarter and not harder, and I'm going to isolate the x in the second equation. Now you don't actually have to do that right now, but I just want to show you if I decided to take the second equation and isolate the x in the second equation, look at how easy that was. I've already got x by itself in one step. It's so much smarter when the coefficient is 1. That's the variable that would be for step 1. That's the smartest choice. So understanding step 1 is one of the things we have to understand first, is how to isolate and which one to isolate. So let's look at problem number 2. So as I'm erasing, look at problem number 2. Which equation? Top equation or bottom equation? And which variable do you think would be the smartest choice to isolate? So if you said the top equation and to get the y by itself because it has that coefficient of positive 1, you are correct. This would be the smarter choice to isolate. Now, isolating this x here wouldn't be too bad, but watch what happens when I isolate the x. It's not too bad. I would have to subtract y from both sides. Then I'd have to divide out the negative 1, and then I'd finally get x by itself, right? I finally got x by itself. But it's just better, right? If I had a choice, I would have isolated the y, because I could just then move this over to the other side, and then I get y equals x. So on number 2, that would be the best. For number 3, the y would be the best choice. And on number 4, we have lots of good choices. So on number 4, there's a ton of good choices. Like any one of these would be great choices to isolate for step 1. Remember, you only have to isolate just one variable, just any variable, just one. So let me show you what I mean. So let's look at number 5. In number 5, it says to solve the system by substitution method. So step 1 is to either get x equals or y equals. And I'm going to choose the bottom equation, and I'm going to get that y by itself. So to do that, don't I want to subtract 2x from both sides? Because doesn't that leave me y equals negative 2x minus 10? Remember, these are not like terms, so you can't combine them. So I took this top equation and I subtracted 2x from both sides so that I could get the y by itself. So step 1 is done. I isolated and got y all by itself by using my algebra skills. Step 2 is to substitute. So remember what equals means. Equals means that wherever you see a y, that y could come out of the game and negative 2x minus 10 could go in place of wherever you see a y. So I'm going to take out the y in the top, and I'm going to actually substitute this in place of that y. So I'm just going to recopy it for a second so we can see it better. So I recopied the top equation, and I'm going to take out the y. So the y is going to come out of the field, and in its place, I'm going to put the negative 2x minus 10. So if I do that, that's 3x minus, there's where y used to be, then there's an equals and a 0. And I'm going to put 2x minus 10 where the y used to be, and that's called the substitution property. So that's substitute. And that's what step 2 is. Step 3 is to solve this equation. So remember, this is like a quote, so we're going to multiply by negative 1. So we're assuming you remember your algebra skills. So we're going to do 3x, and the negative 1 times negative 2 is positive 2x. And the negative 1 times negative 10 is positive 10. And I'm going to combine like terms. So 3x and 2x is 5x. I'm going to subtract 10 from both sides. And then I'm going to divide. So I'm running out of room. So I'm going to divide by 5 because I'm undoing multiplication. So I'm undoing multiplication by division. So that gives me x equals -2. So yay! Because remember, we're trying to find the x and y value that would make that a true sentence. So far, we know that x is -2. So now step 4 is now that we know that x is -2, we still have to go find y. So remember what this means. Wherever I see an x, I can replace it with -2. So I'm going to go back up to this equation, which was y equals -2x minus 10. And I'm going to take out the x and I'm going to put -2 in its place. So that gives me y is -6. So now I have my final answer of can erase and there's my final answer. There's my solution. Right? So -2, 6 is my solution. So first I isolated any variable of my choice. I chose this y, second equation. I used my algebra skills to get y by itself. Then I took the equation up on top and I took out the y and substituted -2x minus 10 in its place. Then I solved this equation using my algebra skills. And then I went back for step 4 and I resubstituted. So I took out the x out of the game and I put -2 where the x was, because that's what this says I can do. And I could have put it into either of the equations. Now, how do I know if I mean, maybe I made a mistake, right? Isn't it possible that I made a mistake? So step 5 is to actually check to see if you made an error. So I'm going to erase this real quick and let's do the check and see if I made a mistake. So these problems take up a lot of room. You get better at it. So let's check. So to verify or to check to make sure we didn't make a mistake, remember I'm thinking x should be -2 and I'm thinking y should be -6. So I'm going to take the top equation and wherever I see an x, I'm going to put -2 and wherever I see a y, I'm going to put -6. Oopsie. Got ahead of myself. And I like to put a question mark, right? So be careful because there's a negative and I'm putting a negative. So that gives me 3 times -2 is -6, and a negative times a negative is a +6, and -6 plus 6 is 0. So yep, sure enough, it worked for the first equation. So for equation 1, it made it true. Let's see if it works for the second equation. The second equation was 2x plus y equals -10. And we're saying x should be replaced with -2, and we're saying y should be replaced with -6. Does that equal -10? Order of operations says you have to do multiplication first, and -4 plus -6 is -10. Sure enough, it worked for the second equation as well. So we know that we actually do have the correct equation and we didn't make a mistake. Yay, we did it right. No mistakes. Otherwise, I'd have to go back and look for a recopying error, a substituting error, a multiplying error, a sign error, a distributing error, right? I'd have to go back and look for an error. So that's the main idea. So now let's look at 2 more examples and walk you through those examples, going through each of the steps. Go back and make sure that you copy down the directions, the steps, and practice memorizing the steps, but think about why we're doing what we're doing, and come back with questions the next day. All right, have a good day. You get faster with these as you start to kind of pick up the idea. You'll get through them a lot faster. It's going to take a while to do your homework at first because it's still really new. Okay, step 1. Do you remember what step 1 is? Is to isolate any variable of your choice. And I go, wait a minute, isn't x already isolated? Oops, didn't want to. Yeah, x is already isolated. So isn't step 1 already done for us? Yep, step 1 is already done. It's already isolated. So in your notes, what does step 2 say? Substitute. So remember, this says that x can come out of the game, and in its place, so x can come out of the game, and in its place is going to go negative y minus 2. So when I substitute and take out that x and replace it with negative y minus 2, and then equals, and then 3y plus 6. So all I did was take this out and put all of this where it was, and I still have my equals, my 3y, and my plus 6 that I had to recopy. That was my substitute step. That was step 2. Step 3 is to then solve. So I'll just put step 3 is to solve. Now, notice that there are variables on both sides of the equal sign. And there are lots of different ways to solve linear equations. Lots of different ways. So lots of teachers teach it lots of different ways. But when I see variables on both sides, I like to undo one of the variables. And that way all of the variables are right away on one side. Remember, that means 1y, so that's 4y plus 6. And then I'm going to undo adding 6 by subtracting 6. Now I've got all my variables on one side and 8 on the other. And then I can undo multiplying by 4 by dividing by 4. So at this point, the expectation is that your algebra skills will be really good. So when we say to go solve, you're like, oh yeah, I don't need to watch this. I know how to do that. And you can just go to it. And so don't we have one of the answers? Yay! We've got y. So remember, we were looking for the x and the y value. And we now have that y is negative 2. We're still looking for x. So how are we going to find x? So now find x. So we go up to either equation. So we go all the way back up to the original equations. In either equation, we're allowed to take y out of the game, and we can replace it with negative 2, because that's what y equals means. So I guess I'll take the bottom equation, and I'm going to take y out of the game, and I'm going to replace it with negative 2, because that's what this means. So that gives me 3 times negative 2 plus 6 is what I do to find x. So negative 6 plus 6 means that x is 0. So now I have my answer. So my final answer is 0, negative 2. And that is known as the solution. How do we know that it's the solution? Maybe I made an integer error or recopy an error. So if I wanted to, I can check to see if I didn't make a mistake. And I'm going to take the first equation, and I'm going to put 0 where the x is and negative 2 where the y was. And I'm going to check to see if that balances. So a negative times a negative is a positive, and 2 minus 2 is 0. So yep, it made the first one true. Now let's see if it makes the second equation true. The second equation was x equals 3y plus 6. So we're going to put a 0 where the x used to be, and we're going to put a negative 2 where the y used to be, and we want to know, is that really a true sentence? So order of operations says you multiply first, and then you can add, and sure enough, it did work for both of them. So that means we know for a fact that 0, negative 2 made both sentences true. So we did not make any errors when we were doing our substitution method. We didn't make any mistakes. You'll get better at it. You got to take your time. You got to slow down. That's why we're not giving you very many problems for homework, because we want you to take your time. Don't go so fast. Let's try one more. Okay, problem number 7. Step 1. Do you remember what step 1 is? Isolate any variable of your choice. Hey, wait a minute. Isn't the second equation, isn't the x already by itself? So isn't the x already isolated? Yep. So I like to put a little cloud around that. So step 1 is already done, huh? It's already done for us. So step 2 is to take the other equation, 4x plus y equals -3, and we're going to take x out of the game, and in its place we're going to put 6y minus 7. That's called substitution, and that's the second step, is to substitute. So there's 4, there's where x used to be, then there's a plus, and then a y, and then an equals, and then a -3. And I'm going to put in place of where x used to be, I'm putting the 6y minus 7. Right? So that's the substitution step. And then that's step 2. Step 3 is, what do you think makes the most sense next? Yeah, to solve. So now we're going to solve for y. Remember, this means 4 is being multiplied to both of those. So the 4 times 6 is 24y. 4 times -7 is -28 plus, and doesn't that imply 1y? And then when you're solving, there's lots of ways you can do it. I'm going to combine like terms because they're on the same side of the equal sign, and they both have y, so I can say I have 25 y's. And then I can add 28 to both sides. Be careful when you're doing your integers. We've got more positives than we do negatives. So our answer is going to be positive 25, and then we're going to divide by 25, and then y equals 1. Yay! Right? We have one of our answers. So one of our answers was y, so we now know that y is 1, and then we're going to go back up to either of these equations, and we're going to take y out of the game, and we're going to replace it with 1. And I'm going to use the bottom equation because that seems the smartest choice. And I'm going to take y out, and I'm going to replace it with 1. So that gives me x equals 6 times 1 minus 7, and 6 minus 7 is -1, so that means x equals -1. So I think we have our answer. And we like to write our answer as an ordered pair. Maybe we made a mistake, right? Possible. Maybe we made a mistake. We could show the check. Do you remember how to show the check? I'm going to leave the check for you and leave the check for you to do on your own to see if we made a mistake or not. But I don't think we did. Okay, that's the substitution method.